Good morning, everyone, and Jai Hind. I am Anupam Kumar Saini, Assistant Professor, AKGEC, Ghaziabad. Today, I am going to discuss about the proposition logic. This is the important topic for second year student of IT, CSIT, AIML, data science, and various computer science discipline students. This topic is from Unit 3. So, start with proposition logic. What is proposition logic? A proposition logic or statement is a declarative sentence that is definitely either true or false. If we can answer a question in true or false form, then it is known as statement or propositional logic. For example, if we write here sum of 2 plus 2 is 4, then answer will be yes or true. And we can take another example. Today's weather is nice, then answer is true or false, means another example, 2 and 2 is 5, means sum of 2 and 2 is 5, then answer will be false. So, when we answer any statement in true or false form, then this is known as proposition logic. Here in propositional logic, we represent the statement in the form of symbols. Symbol we use here is P, Q, R, S and so on. And logical constant for propositional logic are true or false. Any statement may be it true or it may be false. So, what are the there are various logical connectives are used for propositional logic. One of them is and, other one or, implies, if and only if, and not. These are the basic logical connectives used for propositional logic. These logical connectives are used for combining simple propositions to make more complex one proposition. So, we can say that simple propositions are combined into more complex one using logical connectives, and these logical connectives are and, or, implies, if and only if, not. And represent with symbol and or represent with symbol or this symbol, implies is represent with this symbol, if and only if represent with this symbol, and not represent with this symbol. There is another symbol for or is for not. Another symbol for not is this one and this one. These two symbols are used for not. And is also called as conjunction or disjunction, implies, implication, if and only if, biconditional and not negation. So when we apply AND operation, then we can write A and B. Means if there are two sets and we apply AND operation, OR operation, any operation, then we can write it here as A and B, A or B. If we apply implies operation, then we write A implies B, and if and only if, then A biconditional B, A negation. So write it here, negation of A. If we construct truth table for these logical connectives, so for AND there are two sets P and Q. When we apply AND operation, then the truth table will, I explain here, to construct a table. If we construct a truth table for AND, then we write A, B, two different sets, and we apply AND operation on it, A and B. A and B. If the value of A is false, false, true, true, false, true, false, true. If we apply AND operation, then if both symbols are false, then output will be false. If one symbol is false and one is true, then output will also false. Here one symbol is true and one symbol is false, then output is false. If both symbols are true, then output will be true for conjunction operation. If we construct truth table for OR operation, A, B, A or B, false, false, true, true, false, true, false, true. This is false. Right, again for clarity, false, false, we can write anything, but we follow a hierarchy. False, false, true, true, false, true, false, true. Means we write here 0, 1, 2 and 3 in binary number. So if the input is, both input are false, then result will false for disjunction. If any one input is true, then the final result will true. So here A is false, B is false, then output is also false. If any of one is true, then output will be true. So here A is false, but B is true, then result is true. Here A is true, B is false, the result will be true. If both are true, then result also true, means any one should be true, then answer will true. If both are false, then answer will false. So now we construct a table for A implies B. A implies B, false, false, true, true, false, true, false, true. In implies, when the first element is false, then result will true, or both inputs are true, then result will true. We see here in table, if we construct a truth table for A implies B and B implies A also, we take both here. So we check here the first element. If the first element is false, then result will be true. So for A implies B, first element is A, then we check first element is false, then output will true. Here we check the first element is false, then output will true. So first element is false, then output is true. Now first element value is true, then we will check the second one also. If the second one value is false, then result will false. The result will false. This is F. And if both values are true, then result will true. So we see here, if first element is false, then result is true, or both values are true, then result will true. These two conditions are applied for implication. Now we construct the table for B implies A. Here first element is B. So we check here the first value from this table B. The first element here is false, then output will be true. B, second row, value of B is true. Then we'll check the other value. The value of A is false, then output will be false. Because condition is that first symbol should false or both symbol will true. So we check here F, B's value first value B is first element and this value is false, then result will true. And next, the B is true and A is also true, so the result is true. So this is the table for implication, for both A implies B and B implies A. So now construct a table for biconditional. So A, B, A biconditional B, if we take a value false, false, true, true, false, true, false, true. For biconditional, the properties is if both values are true, then result will true, or both values are false, then result will true. If both values are false or both values are true, then result will true. Else result means output will false. If we apply biconditional property and both values are false, then the output will true, and both values are true, then output will true. Only for these two, the output, these two conditions, output will true, else the output will false. So true, false, false, true. So this is truth table for biconditional. For negation, if we construct table for negation, if we consider value A false and true, then negation of A will be, if A is false, then negation of will be true, and if A is true, then negation of A will be false. So these are the truth table for these logical connectives. This is for OR, this is for AND, this is for conditional, and this is for biconditional. Propositional logic, a simple language useful for showing key ideas and definitions. User defines a set of proposition symbol like P and Q, P, Q, R, S. Here, user defines the semantic of each proposition. Here, take an example. It is hot. For this statement, it is hot. We use symbol P. It is humid. we use symbol Q for it, and it is raining, we use here R for it is raining. If I say it is hot and humid today, it is hot and humid today. It is hot and humid today. It is hot and humid today. And we represent it with the propositional logic symbol. So we can write it here P, it is hot, represent P, and it is humid, represent symbol Q, and for and we use and. So it is hot and humid today with the logical connectives. We write it here P and Q. Another example, it is hot and humid, then it is raining. It is hot and humid, then it is raining. So it is hot, for it is hot P, it is humid Q, and it is raining R. So if we write here, if it is hot P. If we write it, it is hot, it will be P, and humid Q, and for and use and symbol. Then it is raining. For if then, so we use conditional connectives. So it is hot and humid. If it is hot and humid, then it is raining. So we write it here, then it is raining. If it is humid, another example, if it is humid, then it is hot. If it is humid Q, it is humid, it is hot P. If you write it here, it is humid, it is hot. For if then we use conditional statement. So Q implies P. For it, if it is humid, then it is hot. So for this way, any statement can convert in symbolic form and represent with the help of logical connectives. These are the model of complex sentences. Means we construct complex sentences with help of logical connectives. So P or Q means element belongs to P or Q, and P and Q element belongs P and Q means common area from P and Q. P implies Q, symbol that is not belongs to P and belongs to Q and all. P biconditional Q, the element belongs to universal set or common area from in between P and Q. These are the complex. We use it in design of complex sentences. For example, a complex sentence we use here, P, right here, P implies, this is expressed for P, P implies Q, P implies Q or, and P implies Q or P implies R. Okay, so question is, P and Q are logically equivalent? Question, or P and Q are logically equivalent? Justify using truth table. So we construct here truth table for this. So we have three variables P, Q, R. P, Q, R. So we construct here P, Q, R, false, 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 true, 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 false, false, true, true, false, false, true, true, false, true, false, true, false, true, false, true. P, Q are three variables. So if there are three variables, then element will 8. So this is our P. So first we construct table for Q or R. We write here Q or R. Then we design. First we take Q or R. In next step we write for P implies Q or R. So what will be the output for Q or R? Q or. In this, when any one element is true, then output will true. If both elements are true, then output will true. So here both elements are false, then result is false. One of them is true, true. Both elements are true, then result is true, false, true, true, true. And P implies Q or P. Then we check here. Now consider P and this one. So if we check, this is the first element. So we check here, the first is false. Where first element is false, then output will be true. So in these 4 rows, output will true, 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 true. And check for other. If the first element is true, then second we go for second element, that is false. So output is false. If both are true, then output will be true. So this is true, 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 this true, this true. So these are true, true, true. Similarly, we construct truth table for P implies Q. So I not writing everything P, Q, R. We take from this table and write it here, the final output P implies Q. P implies Q. So where first element is false, then output is true. So here true, 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 because first element is false. Now we check for next condition. The element of P is true, then go for Q, it is false, then output will also false. This is true and this is false, then output is false. And both are true, then output is will be true. Now P implies R. For P implies R. P implies R. For this we consider table P implies R. The in first row P is false, then output will be true, 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 true. Now check for this. P is true and R is false, output will false. P is true, R is true, output will true. P true, R false, then output will be false. Both are true, then output will be true. This is written here false. Now we apply OR operation on it. P implies Q or P implies R. So OR operation, we get true, 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 false, and both are false, then output will be false. any one of it is true, then output will true. So true, one is true, this is true, true, both are true, then true. So ask about logical equivalent. It is logically equivalent or not? P is logically equivalent of Q or not? Here we see that the output of this P is true, 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 false, true, 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 true for both, for Q and for P. Both the values are same. These are logically equivalent. Some more important topic from this: valid sentence or tautology. If all the values are true, then it is known as tautology. If all the values are false, if all the values of final output is true, then it is known as tautology. If all the values false, if all the true, then tautology. If all false, output false, then contradiction. Okay, thank you.